This is C programming, lecture number 4, exercise number 2. As I told you, this is just an example how we can use programming to solve or to program the solution for different type of problems. And this is just an example taken from mechanical engineering subject. The exercise is that when an object of a weight W is suspended from the center of a massless string, as shown here, the tension at any point in the string is the tension here or here, T equal W divided by 2 cosine theta. Write C program to calculate the tension for any input values for W and theta given by user. That means we have to ask user to enter the value of the weight and the value of theta in degrees, then calculate the value of the tension in the string here or here. And we have to show the message like you see here. Again, hash include stdio.h, void main. We have three variables, t, w, theta. So we have float, cw, theta, say double better because this is just a result calculated, so use double t, comma, semicolon, sorry, and then we have to ask user to print the value of w, to enter the value of w and to enter the value of theta in degrees. So print message, print, please enter the value of W in, as example, Newton. Backslash into go to next line. We can ask the user to enter the W and theta together. We can keep them in different commands. It's up to you. Then we have to scan the entered value, which is a float, outside quotation, save it in the variable W, outside semicolon. We can copy the same command, Ctrl C, Ctrl V. Please enter the value of theta, okay, in degrees. Why degrees? Because it's easier for users to enter the angle in degree, like 30, like 45, like 90, 180. And then scan the value as a float and give it to the variable theta, and take care it is case sensitive. Okay. Now we have the value of W and we have the value of theta. We have to calculate the T. So we'll write T equal W divided by 2 star, which is multiplied by cosine theta. We had to take care about something here. All of trigonometric functions like cosine, like sine, like tan, atan, all of them in C, take the value of the theta in radians, not degrees. So we have to calculate the theta in radian. We can write it here directly or before, it's up to you. So if you want to convert the theta, we can write theta, the new theta equal to the old theta multiplied by, say that pi, my pi, anything, pi divided by 180, semicolon, to convert from degrees to radians. In this case, pi, it's a variable, it should be constant, so we can declare it const float pi equal to 3.14. And I prefer to keep constants as a global variables and normal variables as a local variable. By the way, we can use the math built-in pi, which is m capital underscore pi capital, but we can declare our own, never mind. find our own and use it, no problem. Now we have the value of t, we want to print the message. So we can write for the system of mass, kilogram, theta. According to our message here, for the system of mass equal 10 kilogram, theta equal 30, that means we have to ask user to enter the mass, not the weight, because we know that the weight equal the mass multiplied by g, which is gravity acceleration. So let me do it, no problem. So we can declare W and G and say mass M, and instead of asking user to enter the value of W, the value of mass in kilogram, and scan it and give it to the mass. Now we calculated the theta in degree in radians. Now we have to calculate the weight equal to the mass multiplied by G, and also G should be declared or defined as a constant float. So let me copy the pi again and change the pi to G and change the value to 9.82. So now we have the value of W here and G, and then okay. Now we want to print the result, so we can write print. Now we can write for the system of mass equal to the value which is a float, and we can keep just 2 decimal places like this, okay. The unit in kilogram, okay, and theta of say that also a float with 1 decimal place if you wish, okay, degrees, okay. We can go to next line now. In the quotation, outside the quotation, the first value taken from the mass, which is M, and the second one from T variable. Very good. Semicolon. Now we have to print the message of here the tension equal to the value of LF, because the T, it's double, not float, and you can keep just 2 decimal places, okay. Say the unit in Newton, then go to next line, double quotation, in the instruction, semicolon. From where we'll get the value of this the value here, we take it from the variable called T. We will face a small problem here. I will show you this problem and solve it to you. Now regarding the cosine, it's a function, and this function, it's a mathematic function, so we have to include the library of math 5. Now we have to stop first. We go back to here again, Control V, and change stdio to math. Okay, run the program now. Please enter the value of mass, say 10 kilogram. Please enter the value of theta, say 45 degrees. We will get a correct answer for tension, but theta become 69.4 degrees, which is wrong. Why? Because here, as you see, the value of theta changed and converted from degrees to radians. So I prefer to do what here, guys? I will remove all of these. So I will just cut this and remove this line. just keep theta as it is and convert it inside the cosine like this. So cosine of theta multiplied by pi divided by 180. Or you can define two variables, theta degrees, theta radian, and do what you want. Please enter the value of mass in kilogram, which is 10. Please enter the value of theta in degrees, which is 45. As you see, same force exactly, same tension in Newton, but theta still 69.4 degrees. But theta, okay, print the system of mass equal, theta equal, yes, this is the wrong. The wrong that we took the value of wrong variable. It should be theta not t. So run again. Please enter the value of mass in kilogram, again 10. Say that the theta 45 degrees, same, okay, now it's okay in degrees. Thank you so much.